Local AI infrastructure and deployment. The local AI community has a new heavyweight contender. Solar Open 100B GGUF dropped this week, a massive 102 billion parameter mixture of experts model trained from scratch on 19.7 trillion tokens. The clever part, only 12 billion parameters activate during inference, making it surprisingly practical for prosumer hardware. Early benchmarks from Reddit's local Lame community show impressive results. One user reported 122 tokens per second on an RTX 6000, significantly outpacing Cohen 3 Next ADB's 35 tokens per second on identical hardware. The model fully loads into 96 gigabytes of VRAM, suggesting it's optimized for workstation-class GPUs rather than consumer cards. For those running more modest setups, hardware optimization continues to evolve. Systematic power limit testing on RTX 4090s reveals that the conventional wisdom, limit the power bro, holds up under scrutiny. Testing with VLLM showed that 300 watt delivers most of the performance gains over 250 watt, with diminishing returns beyond 350 watts. The sweet spot for performance per watt sits at 300 watt. Pushing to 450 watts buys only to 6 millisecond median time to first token improvement for an additional 100 watts of power draw. Community members are also exploring proper undervolt overclock approaches using LAT on Linux or MSI Afterburner on Windows for even better efficiency. Browser-based inference is pushing into surprisingly practical territory. A developer demonstrated llama.cpp running via WebGPU inside Unity WebGL, driving NPC behavior at interactive rates. The implementation required significant modifications to WGSL kernels to reduce reliance on FP16 and support additional operations for forward inference. Current performance sits at roughly 3 to 10x faster than CPU inference, but still about 10x slower than native CUDA, a gap the developer believes can be narrowed through kernel optimization. Home Genie 2.0 represents a different flavor of local AI deployment. Agentic home automation running entirely offline. The system integrates Llama Sharp with GGUF models, Cohen 3, Llama 3.2, and others, to create an autonomous reasoning layer that receives real-time home state briefings, sensors, weather, energy consumption, and decides which API commands to trigger. The developers claim sub-5-second latency on standard CPUs through optimized KV cache management and aggressive history pruning. Meanwhile, EvalView now offers fully offline agent testing with Ollama serving as both the chat interface and the LLM as judge for grading agent outputs. No tokens leaving your machine, no API cost beyond electricity. AI development workflows and best practices. The AI development community is converging on an uncomfortable truth. Prompt-driven development has hit its ceiling. Cohen's analysis captures the failure mode precisely. Agents making locally clever changes that quietly break global intent. The problem isn't the AI, it's that specifications written for humans describe outcomes, not constraints. PRDs explain what to build, but not where agents are allowed to think, where they must stop, or why certain paths are forbidden. Cohen's prescription draws from two established software engineering disciplines: domain-driven design, DDD, and architecture decision records. DDD provides bounded contexts, clear domains, ubiquitous language, explicit ownership. An agent no longer guesses where logic belongs, it knows its jurisdiction and stays inside it. ADRs transform passive documentation into enforceable structure, capturing why decisions were made, which alternatives were rejected, and what must never be reintroduced. For AI agents, ADRs become hard rails. Combined with execution frameworks like SPARC, specification, planning, adaptive refinement, completion, these disciplines create a governance layer that allows aggressive iteration without eroding architectural foundations. Coleman's parallel analysis identifies 5 practices separating genuinely productive developers from everyone else. First, PRD-first development. Document what you're building before writing any code, making the PRD your source of truth for every conversation. Second, modular rules architecture. Stop dumping everything into one massive rules file. Split by concern, load only what's relevant. Third, commandify everything. If you do something even twice, make it a command. Fourth, the context reset. Planning and execution happen in separate conversations, with planning producing a document that informs a fresh execution context. Fifth, system evolution mindset. Every bug becomes an opportunity to ask what rule or process update would have prevented this. Pratik Kadam's confession of wasting 3 weeks building AI agents the wrong way reinforces the pattern. The mistake most developers make, jumping straight into implementation without planning. The framework that works: plan, implement, validate, iterate. Planning, defining the exact problem, mapping required context, listing expected inputs and outputs, writing pseudo-logic flow, providing examples, represents 80% of the work. The implementation phase then uses AI coding agents like Cursor or Claude Code to build according to the plan. Validation uses AI-generated tests against real scenarios, not mock test cases. Iteration closes the loop, with AI repeating the entire cycle. Some practitioners are pushing further into local-first agentic development. One developer described running Claude Code against localhost 8000, eliminating limits anxiety and ensuring code never leaves the local machine. The setup involves strict coding rules, self-critique, iterative rewrites, 25 times, and testing until it actually works. The real innovation, orchestrating 8 parallel sub-agents to hammer the local LLM inference engine, running for hours in tmux with hooks. It looks like chaos, it smells like burning silicon, but it gets the job done. The coordination overhead, who speaks when, how to merge results, when to retry, ends up being 70% of the work. The agents themselves are the easy integration and knowledge systems. Connecting AI models to enterprise knowledge sources remains a fragmented problem space, but open-source alternatives are maturing rapidly. SurfSense positions itself as an OSS alternative to NotebookLM, Perplexity, and Glean, a system for connecting any LLM to internal knowledge sources and enabling real-time team chat. The feature set has grown comprehensive: support for 100-plus LLMs, local Allama or VLLM setups, 6,000-plus embedding models, 50-plus file extensions including recent Dockling integration, local text-to-speech and speech-to-text, and connections to 15-plus external sources including Slack, Notion, Gmail, Confluence, and various search engines. A cross-browser extension captures dynamic web pages including authenticated content. Role-based access control enables team collaboration with appropriate permissions. The challenge of AI-to-AI interaction for testing purposes is also evolving. One developer building a Claude Code plugin faced an interesting problem. The plugin involves an interactive intake flow with user questions before deciding what actions to take. Testing such interactive systems requires more than unit tests. Ideally, you'd have one Claude Code session interact with another in a debug loop style. The technical reality is messier. Streaming JSON in headless mode offers the closest approximation to true session-to-session interaction, but trapping models in loops and experiencing weird issues where complex plans and simple plans become indistinguishable is common. One practitioner reported running over 5,000 simulations to achieve 17% accuracy improvement with 15% token reduction using a hierarchical Claude.md system with JSON-L files and @linked markdown documents. Properly configured Redis with memory caching and skills reportedly achieved a 700% token reduction, though the implementer acknowledged this is tricky as shit to explain. Specialized AI models and applications. Meta released SAM Audio, extending the segment anything paradigm from images to audio. The model isolates specific sounds from complex audio mixtures using 3 prompt types: text descriptions, a man speaking, piano playing a melody, visual prompts from video frames, and temporal span specifications. The architecture leverages SAM3 for mask generation when doing visual prompting, identifying which visual objects associated sound should be isolated. The practical applications span audio post-production, accessibility tools, and content creation workflows. Both large and base variants are available on Hugging Face, with straightforward PyTorch integration via the SAM Audio and SAM Audio processor classes. Jipu AI's AutoGLM Phone 9b tackles a different domain: mobile phone automation through multimodal perception and ADB, Android Debug Bridge control. The system understands smartphone screens via a vision language model, plans action sequences, and executes them automatically. Users describe tasks in natural language, open Xiaohongshu and search for food recommendations, and the agent handles intent parsing, UI understanding, step planning, and workflow execution. The architecture includes sensitive action confirmation mechanisms and human-in-the-loop fallback for scenarios requiring login or verification codes. Remote ADB debugging enables Wi-Fi or network-based device connection for flexible development. The model architecture matches GLM 4.1 v9b thinking, with MobileRL providing the reinforcement learning framework for online agentic training. On the web automation front, Sentience API addresses a persistent problem: Vision LLMs hallucinating web UI element coordinates. The SDK uses a Chrome extension to prune HTML and CSS, eliminating over 90% of noise, followed by ONX-based re-ranking to produce a small deterministic set of elements for LLM reasoning. The approach trades screenshots and flaky selectors for semantic deterministic action spaces, essentially giving agents reliable coordinate systems rather than hoping they correctly interpret visual information. Section: Development Tools and Infrastructure. Front-end development workflows are absorbing AI assistance in ways that preserve human judgment while automating mechanical tasks. Chrome DevTools MCP, Model Context Protocol, enables developers to maintain visual evaluation while delegating repetitive actions, emulating specific devices, throttling network conditions, setting geolocation, taking screenshots across states, pre-filling forms, and triggering flows. The pattern, manual judgment, automated execution, fits front-end work surprisingly well. Running headless, developers can request batches of screenshots, then review as images, or open a browser and watch forms pre-fill in real time. Video generation tooling continues to mature. Comfy UI LongLook implements free-long spectral blending from NeurIPS 2024 for WAN 2.2 video generation, addressing motion consistency issues in longer sequences. The core technique uses frequency-aware attention blending. Full sequence attention captures overall motion direction, low frequencies. Windowed attention preserves sharp details, high frequencies, and FFT combines them. Without this, models tend toward motion reversal, ping-pong, subject drift between scenes, and ignoring motion prompts. The real payoff comes in chunk generation for unlimited length videos. Each 81-frame chunk produces clean anchors and reliable continuation because motion direction remains consistent throughout. Security scanning infrastructure is also evolving. Cscan provides a distributed vulnerability scanning platform with a Vue 3 front-end, Go0 API and RPC services, MongoDB persistence, Redis caching, and horizontally scalable worker nodes. The architecture integrates HTTPX with WAPalizer fingerprinting, 30,000 plus rules, Nuclei SDK, 800 plus custom POCs, and FOFA Hunter Quake API aggregation for asset discovery. The container-based deployment via Docker Compose suggests growing recognition that security tooling needs the same infrastructure discipline as production applications. Data management and security. A painful lesson in container data management surfaced this week. SQLite's write-ahead logging, wall mode, and container volume mounts don't mix well without careful configuration. A developer running Django applications in Podman containers lost SQLite data due to a subtle interaction between wall mode and bind mounts. The systemd service file mounted only the main database file, myapp.sqlite3 slopped.db.sqlite3z, but SQLite's wall mode creates additional files .wall and in the same directory. When the container restarts, these files may not be properly synchronized, leading to data loss. The solution involves either mounting the entire directory containing the database files, disabling wall mode at a performance cost, or using database-specific volume configurations that account for SQLite's multi-file architecture. Air-gapped networks present a different data challenge: how to extract operational data for monitoring without compromising the air-gap's security guarantees. A bespoke solution using 2 Raspberry Pi devices connected via an optocoupler demonstrates the principle of physics-enforced security. An optocoupler transmits signals using light, preventing direct electrical connection and ensuring data flows in only one direction. The send Pi sits on the air-gapped network. The receive Pi connects to the external monitoring network. Custom scripts handle data transmission with reliability prioritized over throughput, appropriate for critical infrastructure where losing syslog or performance data is unacceptable. The approach limits bandwidth but provides hardware-guaranteed unidirectional flow, a property that software-only solutions cannot match. Robotics and reinforcement learning. A NeurIP 2025 best paper challenges long-held assumptions about reinforcement learning for robot control. The conventional wisdom, RL requires shallow networks, 2 to 5 layer MLPs, because sparse feedback, one bit of information after thousands of decisions, makes training deeper networks unstable. The paper demonstrates that the problem was architectural, not fundamental. With residual connections, layer normalization, and swish activation, techniques standard in other deep learning domains but rarely applied to control RL, networks can scale to 1,000 plus layers. The behavioral implications are striking. Gains from depth aren't gradual, they emerge at threshold depths. A simulated humanoid learns to walk upright only at 16 layers. At 256 layers, it learns to vault over walls, a behavior that shallower networks cannot conceptualize regardless of training time. This suggests that complex motor behaviors may have minimum representational requirements that shallow networks simply cannot meet. The findings carry practical implications for robotics deployment. If behavior emerges at depth thresholds rather than improving incrementally, capability planning for autonomous systems must account for step function changes. A 16-layer agent walks, a 256-layer agent vaults walls. What happens at 512 layers? At 1024, the paper demonstrates capabilities in simulation, Brack's MJX physics environments, but the eventual transfer to physical robots will require validating that emergent behaviors survive the sim-to-real gap, that a humanoid claiming to vault walls actually produces the correct joint torques rather than merely logging successful trajectories. Security, and after a year reviewing SaaS applications and their APIs, Daniel Cuthbert's assessment is blunt: a journey of disappointment. With OWASP celebrating its 25th anniversary, the security community has had ample time to establish best practices. Yet robust API security engineering, proper content type handling, HTTP method restrictions, rate limiting, security headers, and most critically, visibility into attack patterns remains rare in production SaaS offerings. Cuthbert demonstrated that building a properly secured API with comprehensive detection is achievable in weeks, not months. The implementation uses fast API with slow API for rate limiting, multi-source IP resolution, X-forwarded for, X-real IP, CF connecting IP, and standard security headers, HSTS, X-frame options, CSP. More importantly, a security event type class provides visibility into security-relevant events, authentication attempts, validation failures, rate-limiting triggers, API enumeration detection, BOLA, broken object level authorization attempts, IDR, insecure direct object reference attempts, 404 scanning patterns, and unauthorized request spikes. The gap between what's possible and what's deployed reflects misaligned incentives. SaaS companies have raised substantial funding, yet deliver APIs that lack basic detection engineering. ASVS 5.0, Application Security Verification Standard, provides a solid foundation for API development in 2026, but adoption requires security to be treated as a feature rather than a checkbox. The request is straightforward: give operators the data they need to detect when someone is attempting brute force attacks, BOLA exploits, or systematic enumeration. The technology exists, the implementation discipline is what's missing.